So today we're going to be talking about trig functions. These trig functions here, we're going to be graphing them. These are more complex than what we've done in the past. So let's just go through these one at a time. And here we go. So it says find the amplitude, the period in radians, the phase shift in radians, the vertical shift, and the minimum and maximum values. Then sketch the graph using radians. So let's look at question 1. Now, I have not done these before, so I will be showing you basically as I'm figuring it out. You're seeing, a very honest look at how I would be figuring this out. So I don't have, the answer key is down here at the bottom, but I won't look at that until later, and then you can see how you're expected to kind of think about these. So the first thing we look at is we kind of try to analyze this function here, and we see that we have a 3 times sine of something. The thing is, as long as all of this is contained in here, so the sine, this value will always be between 0 and 1, right? So sine, regardless of what you put into sine, is always between 0 and 1. It will only output those values. So the only way to get larger than that is if you take the sine and then after that you multiply it by something. So in this case, because we see a 3 here, okay, that 3 is going to mean that we're going to be taking all of our values of sine and we're going to be multiplying them. So something that's, what that means is the graph is going to be kind of pulled. It's going to be stretched vertically. You can think of it as if it's at 0, it's still going to be at 0 because you'll have 3 times 0. But if it's like at 1, then that will go up to a 3. If it's at a half, then that'll be 1.5. So this 3 is going to multiply all of our outputs. And that tells us that the sine function is going to be between 3 and -3. So our amplitude is 3. Okay. The next thing we want to consider is the period. So the period is saying how long does it take for all of the cycle to be complete. So when we think of sine is a cycle, and when one of the cycles is complete, we call that a period. So the amount of time that it takes to complete a cycle is dependent on how quickly the degrees are changing. So usually a period is 2 pi. It's a full rotation. It takes a full rotation to cycle through all the values of sine and to reset up for the next cycle. Now, the way that we change the period is if we change the speed at which those degrees are adjusting. So if we're introducing, for example, 3 theta, like if this was a 3 here, that would mean that the radians would be going 3 times as quickly. So the period would be 1/3 of the normal period, which would be 2 pi radians. If it was a 2 in front of here, then it would be going twice as fast. So the period would be shorter. It would take less time to cycle through. So because there isn't anything there, the period is just the standard 2 pi radians period. go. Okay, phase shift. So what phase shift is talking about horizontal movement. So there's a couple of, and I can show this best on Desmos, I think. We'll do A and then plus B. So if we change the number that's in front of the X, you're shrinking the period or you're extending the period. So you can see it's like a spring. Right? So you're extending the period, so you'll have more cycles, or you can have less cycles. And that's what happens when you change this value. But if there's a value that's being added in the parentheses, what's happening is that the graph moves left and right. It doesn't shrink the graph, it moves the graph left and right. And that's called the phase shift. So this is called the frequency, or it's not the frequency, but it's a factor that affects the frequency. And then this is a factor, this is a number that affects the phase shift. Okay, there's a couple of questions here. Will the period always be 2 pi radians if there is not a factor here, then the period will be 2 pi radians. And in degrees, that would be 360 degrees. Is the amplitude always going to be the number in front of the sign? No. So for instance, let's go ahead and adjust this here. Okay, notice that in this case, the number that we're changing is after the sign, and that's affecting the amplitude. You can see here the amplitude is changing. So in this case, it's not the number in front of sign, it's after sign. So the amplitude is affected by multiplication. And a lot of times when we want to multiply, we do put it in front. So very often it is the number in front, but just be on the lookout for anything that's multiplying the sign value. Then that's going to affect your amplitude. The amplitude is the number being multiplied to the sign. Yes. Amazing how many different equation types are based on mx plus b. Well, I wouldn't say that this is based on mx plus b. Or you mean this part, the inside part? Yeah. Well, there's a multiplication part and then there's a addition part. So when you say mx plus b, it's like you're taking into account the two major types of operations. That's the word. Okay. So our amplitude is 2 pi radians, and our phase shift is that this graph is going to move to the right, 5 pi over 6 radians. So what that means is the entire graph. So let's go ahead and graph this graph, but without this. So let's pretend this isn't here. So sine of 0 radians is 0, and then multiplied by 3 is still 0. Right? And then sine of pi over 2 would be sine of 90 degrees, sine of pi over 2. That's 1, and then 1 times 3 is 3. Sine of pi radians is 0. Sine of 3 pi over 2 is -1. And then sine of 2 pi is 0. And this would be 1 period. This would represent 1 period. You can see that once we get to here, it's set up to just continue the cycle again. So now when we take into account this -5 pi over 6, the entire graph is going to slide this way every single point along the graph slides that way, 5 pi over 6. So 5 pi over 6 is very close to pi. So I'm going to graph this in black. So this point here is going to move to here. This point is going to move to here. Okay, and then every point is moving almost, 5 pi over 6 is almost pi. And the reason why I have to estimate is because the units that are on this graph are not pi over 6. So there's a little bit of estimation going on here, but it's almost pi. So we're going almost pi, almost pi. This one, instead of going to 2 pi, it'll stop short. This one, instead of going to 5 pi over 2, it'll stop short. And then we can even go the other way, right? So there would have been a point here. Right? So this would be down about here. Okay, and then there's another point that's like up here. It looks something like this. So the red graph is kind of the original graph, and then because of this, everything moved to the right. And so we can erase our original graph. And this is the graph here. Will the phase shift always move the graph to the right? Well, let's go ahead and take a look at that. Let's cancel that. Here we go. So if I move this B in the negative direction, the graph moves to the right. If I start it again, if I move it in the positive direction, the graph moves to the left. So the graph will not always shift to the right. Sometimes it shifts to the left. It just depends on which value you're doing here. And the reasoning behind that is based on making these values kind of line up with the regular sign of theta, right? So for example, in this one, if I put sine of 0, that'll be 0, right? But in order to get the same sine of 0 effect, in order to have it still be counting as sine of 0, I have to put in 5 pi over 6, which is a more positive amount. So I have to, because I'm subtracting negative 5 pi over 6, I have to put in a larger number here to get the same effect that I would get here. So the x values for this function are going to be larger, meaning more to the right, compared to this one in order to get the same points. Because I have to make it for the fact that I'm subtracting. So the numbers I'm plugging in have to be bigger to make it reach the same value. So it's reaching the same values with bigger x values. And bigger x values means you're moving to the right. For the phase shift, if the value is negative, like the one on the equation, will the line shift to the right always, and opposite, if the value is positive, it shifts to the left. Yes, that's correct. Now, why does it do that? Right? So if it's positive, it shifts to the left. If it's negative, it shifts to the right. But why? Why does it do that? So I'll let you think about that. But since I am recording this lesson, I don't want to just be recording me doing nothing. I'm honestly not sure. Okay, so let's explain that again. I want you to compare the values of this to the values that you get from sine of theta. Okay. So if I put in a 0 here, what do I get out? I get out a 0, right? So I put in a 0, I get out a 0. Okay. Now let's ignore this 3 for a second. If I want to get the same 0 out, what would I have to put in here? Right. In order to get the same output, what number do I have to put in? Well, I have to make it so that this is kind of counting like 0. Right? So over here on this one, I can just count theta as 0. On this one, I have to put in a larger number. I have to put in 5 pi over 6. That way, I get 5 pi over 6 minus 5 pi over 6 equals 0. And then sine reads that as sine of 0. So because of this minus 5 pi over 6, I have to put in a larger number on the independent variable on the x. So because I have to put in a large number on the x, why did that happen? It's because I was subtracting, right? So the fact that I'm subtracting means that you can kind of think of it as, in order to make up for the fact that I'm subtracting, the numbers that I'm inputting have to be bigger. And input numbers is the x-axis, and bigger means to the right. So that is the reason why when you have a minus, your numbers that you input have to be bigger. So that's why it shifts to the right in order to get the same values. Okay. So the phase shift. Now, I want to make sure that I type this correctly. The phase shift would be 5 pi over 6. And let's just double check that I'm formatting that right. Okay. So the phase shift is just negative 5 pi over 6, which means it moved to the right. So phase shift in radians, 5 pi over 6 radians. The vertical shift, this graph does not have a vertical shift. So there's no, it doesn't slide up or down. Right? When we think of a vertical shift, that's going to be like this, right? This does not happen in our example. And that will happen when you're adding or subtracting something at the end. So that's not happening. There's no vertical shift. The minimum value is -3 and the maximum value is +3. Okay. And to find the maximum and min, I just looked at the top and the bottom of the graph. That was the maximum and the minimum value. So now let's take a look at these. I'm just going to copy and paste these. Let's copy these. I'm going to scroll down to the answer key and paste it. And let's see how we did. Amplitude is 3, period is 2 pi, phase shift is, okay, so they give the directions, which is different than what this says. So that's fine. So we can give the directions. Oops. Vertical shift, none. Minimum value is -3, maximum value is 3. So this is good. Would there ever be a case where a minimum and maximum value are not opposites? Like, could there be a maximum of 3 but a minimum of 4? Yes. So let me give you an example of just that. So let's say that we had 3.5x and plus 1. Oops, minus 1. Right? So because I vertically shifted it down, the center of this graph is no longer at the x-axis. You can see, well, this is at 2.5. That's not right. 3, -5. Oh, I know. Silly me. There we go. So now we've got a maximum at 3 and a minimum at -4. See? So you just look across, right? This is at 3. And then at the bottom, it's at -4. Now, why is that? It's because the center of the graph is actually this line here at -0.5. So you can change the maximum and the minimum. They don't always have to be opposites. Look here, they're even both positive. See? All right. Let's scroll back to the top. So question 2. Find the amplitude. Okay, this is the cosine function. Could you make it so the distance from the maximum and minimum from the center be different? No, you cannot. Find the amplitude. Okay, so the amplitude here is going to be 3. The period in radians is going to be 2 pi. The phase shift, so if we look here inside of cosine, it's just theta. So that means not only is there not a phase shift, but the period wasn't affected either. So the phase shift is none. Vertical shift, again, this one doesn't have anything being added or subtracted, so there's none. And then the maximum and minimum values are going to be 3 and -3. So now let's graph it. So if I put in 0 radians, cosine will be 1. But because I'm then multiplying it by 3, cosine is going to be 3. So I substitute 0 and I get 3. Then I put in pi over 2. Cosine of pi over 2 is 0. And then 0 times 3 is still 0. Then I put in pi. Cosine of pi is -1. And then times 3 is -3. And then 3 pi over 2, cosine is 0. 3 times 0 is still 0. And then cosine of 2 pi is 1. And then 1 times 3 is 3. So our graph, oops, let's see if I can do this. And then it would still cross here and then again down here. So this is our graph. Student question on the test, do you want us to also include that the period is in degrees? Just follow the directions. So if the directions say put the period in degrees, put them in degrees. If it says put the period in radians, put it in radians. Otherwise, you're going to have to choose which one makes the most sense based on the problem. So on the test, it will be a combination. You'll have to choose on each problem. Okay, question 3. Y equals 2 sine of -3 theta minus pi over 2 plus 2. So amplitude first, we can see that we're multiplying the sine by 2. So our amplitude is 2. Okay, then after amplitude, we go look at the period. So the period, here we see that we've got this value is being cycled through 3 times as fast, and it's negative, which means you're going backwards. So in this case, if you're thinking about it just purely kind of pattern recognition, right? The period is always going to be 2 pi or 360 degrees divided by that factor, right? So if that was a 3, it would be 2 pi because that's the regular period length. And if you're going 3 times as fast, then it's 1/3 the size. And so then it's 2 pi divided by 3. If you're going twice as fast, then it would be 2 pi divided by 2. So whatever number is here is going to be dividing our 2 pi. Let's take a look. Okay, 2 pi over 3, right? And what that helps us to understand is that the negative does not actually form part of the period. So our period here can be 2 pi over 3. Our phase shift, we're going to be, every point is going to move to the right pi over 2 radians. And that has to do with this here. And then the vertical shift, okay, now we have a +2 here, so our vertical shift will be up 2. And the maximum and minimum values. So let's think about that for a second. Our amplitude is 2, and the shift went from this being the center to this being the center. So our graph is going to look something like this, right? So not quite like that, but the 2 will be the center because it's the vertical shift up 2. And then the amplitude is up 2 and down 2 from the center. So what does that tell us? It means that our minimum value is going to be 0 and our maximum value is going to be 4. Okay, we have a couple of questions here about the period. If the 3 was positive, would the period be 2 pi over -3? No, the period would still be 2 pi over 3. The negative doesn't change the negative value here doesn't change the positive and negative of the period, because the period is just saying what the length of time is. So even if you're going backwards, it still takes the same amount of time. So even if you're cycling through the degrees backwards, the time that you're taking is still always time. It's still always a positive value, right? So the period is still 2 pi over 3. Can you explain how you got the period? So the period, so this is traveling it's cycling through all of the angles at 3 times the speed. Normally the period is 2 pi. So think the normal amount of time that it takes for cosine or sine to cycle through a full cycle is 2 pi. If there's no adjustment to the measurement, the speed at which you're going through the measurements. Because we have a 3 here, it's going through the measurements at 3 times regular speed. So instead of it taking 2 pi, it takes 1/3 of that because it's going 3 times as fast. So the time that it takes is reduced because it's going faster than normal. Student asked a question. So basically the value will always be positive for the period. Yes, because it's just time. How does the negative affect the period? It does not. Could you go over how you found the phase shift? Okay, so the phase shift, again, having to look here, right? And what the phase shift is saying, it's saying that we're subtracting a certain amount from the, graph before, like from the input value. So in order to get the same input value, you actually have to input a different amount. Let me double check. Now that I think about this, let me double check the phase shift is right pi over 2. It's actually left pi over 6. So why is that the case? Why is it left pi over 6? Okay. I'll have to come back to that one, I think, because the bell did ring. So I need to wrap up this question as best I can. So this one would be left pi over 6. And the reason behind that has to do with it has to do with the fact that your input, this theta here that you have here, is being multiplied by 3 before it's being put in here. So it has to do with this -3 is interfering with the way that the phase shift is working. I suppose I could just tell you, and then I'll give you the full explanation tomorrow. So what's happening is the phase shift is you're dividing this into this. That's what's happening, and I'll explain why. Don't let me forget to explain that tomorrow. So it is pi over 6 to the left. Is it because of the 3 it is multiplied by? It is left pi over 6. Pi over 6 to the left. So I'll explain that tomorrow when I have a little bit more time. Is it because of the 3? It is because of this 3. That is the reason why. So it's affecting the phase shift. And so we've got the period, the amplitude, the phase shift, the vertical shift, minimum and maximum. That's it. So now let's graph it. And then we'll be done. So here's how I would do it. Let's put in 0. Okay, so we're going to input 0. And then we're going to just kind of work through this and solve it. So 0 times -3 is 0. And then minus pi over 2, so that's negative pi over 2. So sine of negative pi over 2 is going to be -1. Okay, so negative pi over 2 means rotate this way, right? And pi over 2 would be here, so that's -1. So sine of negative pi over 2 is -1. Multiply that by 2. So that's -2. And then plus 2 is 0. So we put in 0, solve it all out, we get 0. Now let's put in pi over 2 and see what happens. So we're going to put in pi over 2 in here. This is going to give us -3 pi over 2 minus pi over 2. So -3 pi over 2 minus pi over 2. That's going to give us -4 pi over 2, which is -2 pi. Okay, and sine of -2 pi is going to be 0, so this will be 0. Times 2 is still 0, plus 2 is 2. So when I put in pi over 2, I get 2. Let's try putting in pi over 4. So substitute in here. Let's put in pi over 4. So that's going to give us -3 pi over 4 minus pi over 2, which is 2 pi over 4. That's going to be -5 pi over 4. Okay, sine of -5 pi over 4 is something that I'm not familiar with off the top of my head. So that's going to be that. Can't be right. Sine of -5 pi over 4. Oh, I guess it is right. So we've got 0.7, let's say. So this is 0.7 times 2 is 1.4 plus 2 would be 3.4, so about 3.4. So this is going to be about here. And so on and so forth. We are running a little bit low on time. So let me just answer these last questions and then we'll finish this one up tomorrow. Why do you get 2 when you got -2 pi? So it's because, so if you got -2 pi in here, so this would be -2 pi, right? What's the sign of -2 pi, right? So -2 pi means you're rotating this way and you're rotating around 2 pi, which is rotating back to here. So what's the sign of that? The sign of that, you know, you're back to where you started. The sign of this position is 0. So even though you get -2 pi here, right, this equals 0. So then that would be 0. 2 times 0 is still 0. And then plus 2, right? 0 plus 2 is just 2. So that is how I got 2 out of that. How do you apply the vertical shift to the graph? Actually, the vertical shift is already being applied because this plus 2 is here. Just by the fact that I'm plugging in different values for theta, the vertical shift is already working. It's already being, it's not something you have to apply after the fact. It's already there because we're taking this 2 into account when we're solving. So by including this plus 2 every time that we plug in, right? That's always the last thing that we do is we add 2, is we're effectively taking our y values and we're moving them up 2. So that's, the vertical shift is not something that you have to do separately. It is part of whenever you substitute in a value, it's part of that. Okay. Let's just take a look at how we're doing. So there is, at pi, it has a max, and at 1 it has a 0. Okay, we haven't done that yet. 1 has a 0. Okay, well, we'll have to finish this tomorrow. Have a great lunch, and I'll see you tomorrow.